The science of learning. Are you a teacher who cannot seem to get through to a particular child? Do you have disruptive behaviours in your classroom? And no matter what you've tried, just don't seem to be able to get through? Do you have autistic children and you're trying to do inclusion, but even though you're being told to do inclusion, no one's giving you any real tools? Are you a parent and a teacher? Is one of your children special needs? Do you have special needs parents coming to you saying, our child is not thriving in the classroom? These are standard issues that teachers, parents and therapists come to us with, and which I, in fact, dealt with myself as the father of an autistic child who started non-verbal, incontinent, self-harming, and is now 15 years later or so, driving, working, thriving at school, flying across the Atlantic by himself. So this stuff really works. Now, I do want to have a disclaimer here. We are not therapists, we are not doctors, we are not neuroscientists, but we work with neuroscientists, and we work a lot with doctors, and we work a lot with therapists, and above all, we work with autistic people, and people with ADD, and people with other neuropsychiatric stuff, and they guide us. And when we see what works, we go to the neuroscientists and we have the neuroscientists explain why it works. So this is coming directly from the autists and the people with neuro conditions, and then through them, the neuroscientists, and now to you. So that's the lineage of how it's coming. All right, so movement method. We call it this because movement is essential to learning. You cannot learn, your brain cannot learn really well unless you are moving. Why? Because we are hunting and gathering apes. We are programmed to be on the move the whole time. If you put infants in infant parking where they're too much in front of screens, their brains don't develop properly. If you put old people in old people parking, their brains die. We know this. You've got to move in order to keep your brain animated, which means alive, which means moving. All of these words center around movement. So here is the problem that we're often facing. Let's say this is person A, could be a child, could be an adult. They have a neuropsychiatric thing going on, and frequently what we're looking at is distress, sometimes quite real distress. Why? What's going on? Two things. First, we seem to have always an oversensitive nervous system. We don't know why in autism and other neuropsychiatric conditions the nervous system seems to be hyper or hypo sometimes, responsive to sensory input, but we know it exists and it can shut people absolutely down, and usually these bad triggers are man-made. They are usually industrial in origin. For example, I'm looking at the camera right now, but there's actually a light shining on my face directly into my eyes. I find this incredibly difficult, but I'm tolerating it in order to get the job done. But if I was autistic, if I had some stronger neuropsychiatric condition, it might shut me down completely. Okay, this happens. All right, now the other difference which has often been noted is that the amygdala, which is the fight, fright and freeze part of your brain, is often overactive and therefore producing too much of the stress hormone, which is called cortisol. And I want you to think of cortisol like a pair of scissors. What it does is it momentarily, in a moment of threat, cuts the connection, the brain cells, between the back part of your brain, which is the instinctive part of your brain, and the front part of your brain, which is the thinking, planning, logic part of your brain. It's connected in the middle by the emotions, okay? So if that gets cut, the whole point of this is to keep you alive. It's your reptilian brain, so that you act, you don't think. You don't start thinking, oh, I wonder what Dostoevsky meant in that paragraph in the Brothers Karamazov when an elephant comes through the wall. You drop the book, you dive to the side, and only when the elephant has gone through the other wall do you pick the book up again. So you have no choice in this. Cortisol is there to produce an involuntary reaction that's immediate. If you didn't have it, you'd die because you wouldn't respond to threats. However, cortisol is a little bit like alcohol. It can be very good for you in small doses. Too much of it, flooding your system, toxic. Just to clarify, the amygdala itself does not produce the cortisol. The amygdala sounds an alarm which tells glands near the adrenal glands to produce the both cortisol and adrenaline so that you can move at the same time. Again, we're back to movement. But the point is, if you have too much cortisol in your system, you get sick. So that's why people who are in incredibly stressful jobs and situations and so on end up getting sick. It's why if you're having a huge marital argument, it's probably not the best time to make long-term financial plans, because your logic centers, your planning centers of your brain are actually taken out by the cortisol. You need to go for a half-hour walk, let it flow through your system, better still, sleep, come back the next day, and then you can think again. It makes you unable to think and therefore unable to learn. So a stressful environment that is constantly pressing this oversensitive nervous system and telling the amygdala, oh, threat, 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 puts the person into what we call a vicious cycle that they can't break out of. And this is often presented in the behaviors that you are finding so difficult to deal with. Here we go, vicious cycle of suffering. And the suffering is physical and mental and emotional. So when you're at home with your child, when you're in the classroom, when you're in a therapy situation, you've got to think, how do I break the child out of this negative cycle? Because by the way, if this goes on for too long, years and years and years, too much cortisol can actually produce scarring in the brain. And this is not good. However, the good news is the brain is very plastic. Neuroplasticity. The growing of brain cells. You can regrow the brain very quickly. So here's the solution. Okay, here we call this person B. The solution, oddly enough, is not in the brain. Just as perhaps the original problem might not be in the brain. The solution, oddly enough, is in the part of you that makes you move, which is your booty. It's your hips. Anything that rocks your hips in rhythm creates the antidote hormone to cortisol. It's called oxytocin. Unlike cortisol, which is toxic for you, you can't have too much oxytocin in your body. It's incredibly healthful for you. The first person to turn us onto oxytocin was actually Dr. Temple Grandin, who's probably the most famous autistic person in the USA, if not the world. And when she was looking at the work we were doing with children on horseback initially, she said, the reason why you're getting these great responses is because the kids' hips are being rocked in rhythm for a long period of time. They're getting flooded with oxytocin. I said, why would that make a difference? She said, well, because what that does is it calms the nervous system. And at the same time, it tells the amygdala that there is actually no elephant coming through the wall. Switches off. No more cortisol. Or less cortisol. No cortisol right this second. Okay, so we then went and spoke to neuroscientists at the University of California, San Diego, and they confirmed what Dr. Grandin was saying and said, what you guys have done with movement method is you've stumbled into a way of switching off the cell danger response in the brain. And this is crucial for learning. But they then turned us on to some other benefits of what we were doing, because we didn't know why we were getting not just a better response emotionally and behaviorally from the child, but also why were they learning so well? Why were we able to teach math and science and this kind of thing to kids that had been kind of written off completely academically? And above all, why were kids starting to communicate, talk, etc.? So what oxytocin does, if you're going to rock your hips in rhythm, you have to relax your psoas muscle. The psoas muscle is the thing, it comes all the way from sort of just below your rib cage really to halfway down your thighs and through your pelvis. It's connected to your amygdala. It's what makes you go into the fighting stance where you can both fight, protect your organs and run away, all in the same motion that keeps us alive. If your psoas is contracted, you're working through the amygdala. If your psoas can relax, relax, you start to produce oxytocin. And oxytocin isn't just the antidote to the cortisol and health giving. This is what's amazing. It's the hormone, you need to write this down because it's so important, hormone of communication. Now, why would we have a hip-rocking mechanism that makes us produce a hormone of communication? Why is that important to our species? We can understand why the cortisol and the amygdala is important, because it wants to keep us alive. Communication. Okay, so the human brain is about the largest brain for its size relative to the rest of us, the skull, etc., of pretty much any other organism that's on the planet. So when we birth a baby, the brain is at the max capacity that the mother's birth canal can accommodate to actually get that baby out, which means that the brain then has to grow about another 20 years before it's fully functional, and that young juvenile Homo sapiens sapiens, that's us, can go off and be independent. What other mammal is like this? I mean, even the mammals with really big brains, like elephants or like dolphins and this sort of thing, the calf or the young dolphin comes out and pretty quickly they're running with the herd, they're swimming with the herd. Not so humans. Okay, so it takes 20 years for that brain to grow, which means that particularly in the wild setting, if one parent leaves because of the immense difficulties of bringing up a human child, and those of you that are parents know exactly what I'm talking about, then the survival of that offspring go down considerably. So you need to have a communicative bond between the parents so that they can be motivated to figure out the way through the many, many problems that are going to occur. When they make the baby, during intercourse, they're creating a lot of oxytocin, they're feeling good, and there's a great desire to communicate. But what about after that, when all the difficulties come, lack of sleep, diapers, tantrums, and adolescence, etc., etc.? You need the parents to continue to want to communicate. So anytime we rock our hips in rhythm, when we dance, when we ride, when we play on play equipment, when we engage in any kind of recreational activity, basically that involves movement, we're going to relax our psoas muscle and we're going to produce oxytocin. So this is why we have it. It's called the mammalian caregiving system, and that's why it's also associated with bringing down birth contractions and breast milk. Everything about quality of life, thriving, is oxytocin. All right. But there's more. Oxytocin brings you to this, but we now want to bring our person to this. Excuse my wonky light bulb. Bing! Bong! We want to open up the intellect. Now, in this situation, we can't access the intellect because the cortisol is standing in front of it like a guard dog in front of a locked door. A lot of people often think that there's an intellectual disability, for example, with autism. There probably isn't actually. There can be a co-diagnosis of an intellectual disability alongside autism, but with autism itself, the intellect is usually intact. It's just that you can't get to it. Okay, so how do we get to it? Well, the oxytocin, of course, comes along, tells the amygdala to shut down, at least for a while. It's like it throws a steak to that guard dog, and the guard dog rolls over, has a little scratch under the belly, and now you can walk into the intellect, which is here. This is the prefrontal cortex, and that part of your brain, I hope you can see this on your screen, cortex. This part of your brain is logic, reason, planning. Figure and emotional regulation, figuring stuff out and handling problems. If you can't do this on planet Earth, your chances of survival are not very strong, okay? That's why we have this prefrontal cortex here. Okay, so now we have an access to that, and there's more. Anytime you are moving and problem solving, you're usually balancing in some way. Think play equipment, think bouncing, think trampolines, think a yoga ball that you might be sitting on at a desk even. And when you balance, you activate your vestibular system, which is in your inner ear, and it's to do with balance, but it's also to do with attention and long-term learning. So anything that you learn while you're moving in this way of problem solving, how to balance your body, makes it stick in the brain. Amazing, eh? But there's more. Your cerebellum, what they call the little brain, produces a series of cells called Purkinje cells with a funny name. I'm going to write them down. You want to write this down too, because Purkinje cells are your friend. Purkinje cells seem to be associated with both motor skills and social skills. And they act like a communication network in the brain, like an intranet, if you like, that makes all the different parts of the brain communicate with each other properly. Now, here's an interesting thing. A lot of autopsies on adult autists have shown not just an overactive and enlarged amygdala, but a deficit of Purkinje cells. Okay, by the way, why have they got this funny name? They're named after a Czechoslovakian scientist in the 19th century who discovered them, whose name was Purkinje. We call them Purkinje cells. So this might explain why different parts of the brain don't seem to be communicating with each other with autism. Perhaps you might get a low-functioning child who can remember all the football scores of the local team for 10 years, but can't go to the toilet. Or you might have a very high-functioning person with great math skills and terrible social skills. That could be because of this deficit of Purkinje cells. Well, guess what? When you engage in these same moving and problem-solving activities, your brain, your cerebellum, produces large amounts of Purkinje cells. And what starts to happen is you can begin to observe brain function beginning to normalize really quite quickly. But you've got to do it a lot. You can't just do it for 1 hour a week in some therapy session and then go home and sit in front of the TV. You've got to move and move and move and move. But luckily our bodies are hardwired to do this. So we want kids to be moving as much as possible. Let's say you're in the classroom. Can they move on a yoga ball? Can they move between a place on the floor and the chair? Can you circulate them around the room from time to time? If you're in an apartment, we live in this 3-bedroom apartment that I'm in right now talking to you. We set up the living room a bit like a gym, so our kids can run, bounce, swing, do what they need for their brains, and we're outside a lot. The Purkinje cells are really important for brain function, normalizing brain function, again through communication, but this time with its own parts, because the brain has billions of neurons that all need to communicate. And there's more. Okay, this is the final piece on the cake, and it's amazing. When you move and problem solve, your IQ actually goes up. What do we mean? We're back to the neuroplasticity again, the growing of brain cells. There is something that happens when you move and problem solve that makes your brain produce this protein. It's a protein. It's called BDNF. It's an acronym, okay? And it stands for brain derived, you really want to write this down, chaps, neuro, meaning brain cells, trophic, growing, so growing of brain cells, factor, effect. So basically the brain producing more of its own brain cells, but like in a big way. Okay, so think about it. If you're a hunting and gathering ape, you're going out there and you need to hunt antelope. And out there where you're hunting the antelope, there's dangerous animals like lions, like hyenas, like elephants and so on. You've got to figure out your way around those. The weather is changing. This is going to affect the hunt. It's massively social and strategic. You've got to strategize how maybe the animal is hunting you back or will defend itself. So you've got to plan with your co-hunters. Then let's say you get the animal after tracking it, which is incredibly difficult to do. And you're trying not to fall and break your leg, by the way, while you're out there. Then you have to butcher that animal and carry it home, which is a whole other strategy. Imagine if you are a female and you are gathering wild foods. again, intensely physical. You've got to climb in the tree and shake the fruit or the nuts down. You've got to dig roots up from the ground. You've got to walk long distances to find these things. And a moment's inattention can kill your family, because there are many plants where a toxic plant and a nutritious plant look almost identical. And if your brain isn't on high alert, that could be the difference between total death for your family and your family surviving. So our brains have evolved this BDNF thing to make our IQ go up when we move and problem solve. And finally, some fairly recent studies have shown that if you add great joy to this euphoric experience, which is, again, comes down to oxytocin and the other bliss hormones, serotonin, dopamine, and so forth, you can magnify the neuro-trophic factor massively. So that's why play is the best way to learn. It's not some idea, it's not some hippie idea that, oh, it's just nice if kids play. We are hardwired to learn this way. It's how we actually learn most effectively. So math games are always better than just stuff at the whiteboard. Becoming the number with your body, much, much better. You'll find on the lesson plans and other mini courses on our website, ntls.co, lots and lots and lots of strategies for how you do this in the classroom, in the home, and in a therapy environment. And let's say you're a teacher where you have to really stick to curriculum. Don't worry, we have worked out how you do this as a single teacher in a class of 30, even with disruptive, unruly middle schoolers. I'm serious, this stuff works, and it doesn't take very much to know. Go on our website and we'll give you all the strategies for how to do it. But it's pointless to do it unless you know what the problem is and what the solution is. And just here, the problem was a vicious cycle. With this, you end up in a positive cycle. Okay, it doesn't take very long to go from the problem state to the solution state, or if there's a meltdown, from the solution state back to the problem state. But once you know this neuroscience here, you can retrieve a negative situation really, really quickly by knowing how to create oxytocin through certain hip rocking movements, and then engaging the child in various kinds of moving and problem solving activities that create the Purkinje cells that activate the vestibular system, that create the BDNF in the brain, hopefully magnifying it because the kid is enjoying themselves so much, and that all of this gives us access to an increasingly strong and developing prefrontal cortex, which is our intellect, our IQ, that we value so highly. Now, I am an engaged amateur. I'm an autism dad who had to figure out what to do with my son, and I was successful. But I was successful only because I got mentorship from autistic people like Dr. Temple Grandin, and then after following their advice, I went to neuroscientists like Dr. Robert Navio and Alison Moitri at the University of California, and had them explain why it was working. And we found out that indeed this worked across the board, not just with autism, but with any neuropsychiatric condition, in fact, with any kid or person or adult. Why? Because our brains are all essentially the same. Okay, some people might have an overdeveloped amygdala, some people might be having a deficit of Purkinje cells, but these are relatively small differences. What's also interesting is that autistic people tend to be very authentic. They tend not to lie in order to please you. So if something works for someone on the autism spectrum, it's probably going to work across the spectrum of humanity. So this is the key, chaps, to how it works. All right, last disclaimer. We are not neuroscientists, we are not doctors, and we are not therapists. However, what we have found here is used by all of those people, and by teachers and of course parents all over the world now, in about 26 countries, I think 27 now, because this neuroscience works. This is now used by teachers, parents, therapists, even doctors in 26, 27 countries around the world, because the neuroscientists have shown us that this really seems to work. Okay, To find out more, to go into more detail, because this is a very simplified version of what's going on, and to look at the lesson plans and the really specific strategies for, okay, my child can't go to the toilet, okay, my child is really disruptive in school, okay, my child can't sit still, okay, my child won't keep his clothes on, okay, my child is exhibiting violent behavior, etc. We have all of those modules and mini courses on our website, ntls.co, not .com. We couldn't afford the .com. We are .co. NTLS New Trails Learning Systems.co. Go on there. This is all explained again, and then in more detail. There's I think about 200 now modules and mini courses that you can take that address all the specific problems that you're dealing with. But until you know this, there's not much point trying to apply them. This is the key.